Hello everyone, this is Kishore Patil and I welcome you to my YouTube channel Maths for Science. Today we are going to see the first chapter from the Science and Technology of Standard 9, that is the laws of motion. We all are very well known that Isaac Newton has contributed so many things in the field of motion. Okay, let us see the two concepts related with the motion. One of them is the displacement and other one is the distance. Now see, what do you mean by the distance and the displacement? Distance is the length of the actual path traveled by an object in motion, while displacement is the minimum distance between the starting and the finishing point. Okay, let us see. If someone wants to start from Sheetal's and Prashant's house and wants to go to the school, if he takes the path from Sheetal's house to the Sangita's house and then Sangita's house to the Sheetal's house, but other one can be take path directly from Sheetal's house to the school. So this is the minimum distance, while this one is the actual path. So that actual path is called the distance, while this is the displacement. I am taking one more example. We all know that Earth is revolving around the sun. Suppose I am taking, here is the Earth and Earth revolves around the sun. This is the sun. I am taking, this is the sun. Suppose Earth is revolving starting from here, and after one complete revolution it again comes at the first point. So this entire circumference is the distance. But what about the displacement? Displacement is 0 because its starting point and final point is same. Okay, let us see the distance and the displacement. The distinguish question may be asked as distinguish between the distance and the displacement. Distance. Distance is the length of the actual path traveled by an object, while displacement is the minimum distance between the starting and the finishing point. Distance is the scalar quantity while displacement is the vector quantity. Now what do you mean by the scalar quantity? For the explanation of the quantity, if direction and magnitude both are required, is called the scalar. But if only magnitude is sufficient, this one is the scalar quantity. If direction and magnitude both are required, is called the vector quantity. So for distance, explanation of the distance, magnitude is sufficient. So that is why distance is the scalar quantity, while whenever magnitude and direction both are required for the explanation of displacement, it is called the vector quantity. Okay, distance is always greater than the displacement or equal to the displacement, while displacement is always less than or equal to the distance. Here you can see this is the distance and this is the displacement. So displacement is less than the distance. Okay. Distance traveled is always positive, while displacement may be positive or negative or 0. You have seen here in the condition of Earth completes its revolution and having some distances, so it is always positive, but its displacement is 0. Now let us see the speed and the velocity. Speed is related with the distance while velocity is related with the displacement. See here. Speed is the distance upon a time. We know that distance is the scalar quantity Therefore, speed also a scalar quantity and velocity is the displacement upon time. If displacement is the vector quantity, velocity also the vector quantity. Now, what is the definition of the speed and velocity? Speed is the distance covered by a body in unit time, while velocity is the displacement that occurs in unit time is called the velocity. Okay, speed is equal to or greater than velocity. We know that distance also equal to or greater than displacement, and in terms of velocity, velocity is equal to or less than speed. Similarly, displacement also equal or less than distance. Okay, now see the effects of speed and direction on velocity. See, you can see three pictures here. In the first picture, motorcycle is going on a straight line. What will be the effect on the velocity of the motorcycle if its speed increases or decreases but its direction remains unchanged? Straight way is there, so therefore direction is unchanged. If direction is unchanged, so just magnitude of the speed or the you can say magnitude of the velocity goes on changing as per the speed changes. In the second condition, if Sachin changes the direction of the motorcycle keeping its speed constant, what will be the effect on the velocity? If speed is constant but the direction it changes, then for the velocity its direction also goes on changes, and we know that in certain condition it may causes accident. In the third situation, speed and direction both are changing. So if speed and direction both are changing, velocity also changes as per the what are the changes in the speed and what are the changes in the direction. We know that the first scientist to measure speed as the distance upon time was Galileo. So we can say that Galileo discovered the formula how to measure speed. The speed of sound in dry air is 343.2 meter per second, while the speed of the light is 3 into 10 raised to 8 meter per second. We know that speed of the light is near about 10 raised to 10 times much higher than that of the speed of the sound. The speed of revolution of the earth around the sun is about 29,770 meter per second. Circular motion. If an object moving along a circular path of radius r, it takes time t to come back to its starting position. If an object moving along a circular path, then its speed can be determined by using the formula speed is equal to circumference upon time, and we all know that circumference of the circle is 2 pi r. Therefore speed is equal to 2 pi r upon t, where r is the radius of the circle and t is the time taken. Let us see the acceleration. Okay, we all know that what is the velocity? Velocity, it is rate of change of displacement, and acceleration, it is the rate of change of velocity. Acceleration, it is a rate of change of velocity. It is a vector quantity. See, displacement is the vector quantity, velocity is the rate of change of displacement, that is why velocity is a vector quantity, and acceleration is a rate of change of velocity, therefore it is also a vector quantity. Now suppose v is the final velocity, u is the initial velocity, and A is the acceleration, then A is equal to V minus U. See here, A is equal to V minus U upon T. V minus U, that is change in the velocity, upon time, that means rate of change in the velocity. Units of the acceleration in SI system is meter per second square and CGS system is centimeter per second square. Types of acceleration: uniform acceleration, non-uniform acceleration. If the change in the velocity is equal in equal intervals of time, the acceleration is uniform. इक्वल टाइम इंटरवल में इक्वल चेंजेस हो रहे हैं इन द वेलोसिटी, देन वी कैन से दैट दिस वन इज द यूनिफॉर्म एक्सेलरेशन. बट इफ द चेंज इन वेलोसिटी इज unequal in equal intervals of time, change in the velocity is unequal, then we can say that the acceleration is a non-uniform acceleration. Kinds of the acceleration: positive acceleration, negative acceleration, and zero acceleration. When the velocity of an object goes on increasing, धीरे धीरे बढ़ता जा रहा है velocity, then we can say that positive acceleration. Negative acceleration, yes, negative acceleration, when the velocity of an object goes on decreasing, it is said to have negative acceleration, or you can say as retardation or deceleration. C. Zero acceleration. If the velocity of the object does not change with time, it has zero acceleration. Newton's first law of the motion. Remember, all these three laws are the very important in the field of physics. Now let us see first what is the Newton's first law of motion. An object continues to remain at rest or in a state of uniform motion along a straight line. Object always remains at state or in a state of uniform motion in a straight line unless and until an external unbalanced force acts on it. Unless and until an external unbalanced force acts on it. जब तक बाहर का कोई फोर्स उस पर एक्ट नहीं करता, तब तक ऑब्जेक्ट रिमेन्स एट either in state or in uniform motion along a straight line. So that is why the statement of the Newton's first law is an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Okay, let us see the Newton's second law of motion. The rate of change of momentum, Before that, let us see what do you mean by the momentum. Okay, let's see what is momentum. Momentum is the product of mass and velocity of an object. Mass and velocity. Mass, that means m, and velocity, that means v. So what is the unit of mass? Unit of mass is kg, that is kilogram or gram, and velocity is meter per second or centimeter per second. So that is why momentum has magnitude as well as direction. Its direction is the same as that of the velocity. So direction of momentum and direction of velocity are always same. In SI system, the unit of momentum is kilogram meter per second, while in CGS system it is gram centimeter per second. If an unbalanced force applied on an object causes a change in the velocity, if an unbalanced force applied, then it is also causes the change in the momentum, because we know that momentum is the product of mass and velocity. So whenever change in the velocity, it also causes the change in the momentum. The force necessary to cause a change in momentum of an object depends upon the rate of change of momentum. Now let us see the first law. Newton's second law. The rate of change of momentum of a body is proportional to the applied force, and this change in momentum occurs in the direction of the applied force. If some external force causes the change in the momentum, this change in the momentum is proportional to the applied force. What is the magnitude of the force? The change in momentum is always proportional to the applied force, as well as it is in the direction of the applied force. Newton's third law of motion. Every action has an equal and opposite reaction which acts simultaneously. This is important, simultaneously. Every action force has an equal and opposite reaction force which acts simultaneously. So this is the Newton's third law of motion. So first law of the motion, it describes inertia. It describes inertia, while the second law of the motion, it explains the rate of change of momentum, and third law of the motion, it gives the relation between the action force and the reaction force. Now equation describe the relation between the velocity and time. Okay, see here. If O to E, it shows time, while that part OC describes the change in the velocity. And suppose an object initially having the velocity u. Now figure 1.9 shows the change in the velocity with time of a uniform accelerated object. Now what do you mean by uniform accelerated object? Uniform accelerated object, that means there is the change in the velocities. We know that acceleration, it is the rate of change of velocity. The object starts from point D. Object starts from point D in the graph with velocity u. Its velocity keeps increasing, and after time t, it reaches at point B. Now there is a change in the velocity, initial velocity u, final velocity v, initial point is D and final point is B. Okay, initial velocity of object is OD. See here, initial point is this, initial velocity, this line shows velocity. So initial velocity is OD and final velocity is OC. Okay, change in velocity, that mean that OC change in velocity, that means OC minus OD, that is OC minus OD, final velocity minus initial velocity, and time is t. This is time t. Now see here, you can say acceleration is the change in velocity upon time, final velocity minus initial velocity upon time, final velocity is OC. See, this one is OC is the final velocity, and initial velocity is OD. OD is the initial velocity upon time. Now we can write OC minus OD is CD. This CD is equal to, here A is there. A is there. A is equal to OC minus OD. So therefore CD is equal to AT. Okay, let us draw a parallel line to y-axis passing through B. This one is the parallel line. And also draw another parallel line to the x-axis, that is DA. Now we can say from the graph BE that BE is equal to BA plus AE. BA plus AE. So BE, what do you mean by BE? It is V. V is equal to CD plus OD. CD plus OD. Now see here CD. V, that entire part V is equal to CD plus OD. Okay. Now what do you mean by CD? That we have find CD is equal to AT and OD is equal to U. So therefore we can say V is equal to U plus AT. This is the first kinematical equation, or you can say this is the first equation of motion. See carefully and then let us see the next slide. Whenever you want to see it carefully, you can pause it and see it. Equation describing the relation between displacement and time. We are using the same graph, that D is the initial point and B is the final point. Therefore we can say an object covers the distance from D to B. That distance covered by an object during time t, time is required during time t, can be given by the area of the quadrilateral DOEB. See here, quadrilateral DOEB. This quadrilateral gives the distance traveled by the object. Now this quadrilateral is the combination of rectangle, that rectangle, and this triangle, rectangle and triangle. Now what is the rectangle? Area of the rectangle, D O E A, and area of the triangle DAB. Okay. Now we know that area of the rectangle is length into breadth. Length is OE, breadth is AE. So this is why area of the rectangle is AE into OE. And area of triangle is half into base into height. So base is equal to DA and height is equal to AB. So that is why area of rectangle is half into base into height. But we know that AE, that part AE, is U, initial velocity, OE is time, and AB is the AT that we have find in the first one, that is AB is equal to CD and CD is equal to AT. Therefore we can say that AB is equal to AT, that we are using here. AB is equal to AT. So in this equation let us substitute values. AE, that means U, OE is equal to T plus half into AT plus AT into T. let us substitute values in this equation. S is equal to u into t plus half into 80 into t, that is the S is equal to ut plus half at square. This is the Newton's second equation of motion, or you can say the second kinematical equation. You can rewind and check. Let us see the equation describing the relation between displacement and velocity. Okay, again we are using the same graph. This part is the time, this one is the velocity, this one is the initial velocity, that one is the final velocity. Okay, now in the previous one we have find the area of T O E B, which gives us the distance. Now in this way, in this equation, in the second one we have found the relation between the displacement and time, but here in the third one we are describing the relation between displacement and velocity. Okay, see here we have seen that from the graph in 1.9 we can determine the distance covered by the object in time t from the area of the quadrilateral DOEB. By using this area of the quadrilateral we have found the distance, but DOEB is a trapezium, so we can find the area of the trapezium by using the area of the trapezium formula. What is the area of the trapezium? Area of the trapezium is equal to half into sum of the length of parallel sides into distance between the parallel sides. See here सेकंड में भी यही काम किया था, एरिया ऑफ द ट्रेपेजियम ही फाइंड किया था। इसमें भी हम लोग एरिया ऑफ द ट्रेपेजियम ही फाइंड कर रहे हैं, बराबर। ओके, S is equal to area of the trapezium. S is the distance. S is equal to half into sum of the length of parallel side into distance between the parallel side. This one is the formula for the area of the trapezium. Now sum of the length of the parallel side. Which are the parallel sides? OD and BE as the parallel side. Now see here you can see sum of the parallel sides, that mean OD plus BE, into distance between the parallel side. Distance between the parallel side is OE, that one is OE. Okay, or you can say OE. This one is O to E. This one is the distance between the parallel sides. Now S is equal to, let us substitute the values. OD is equal to, we are seeing the this formula. Now S is equal to half into OD. Now what do you mean by OD? OD, that means this one, that is U. BE, BE, that means this one, that means this one, that is V, that we have written here, U plus V. OE, that means this one, it is T. So formula is S is equal to half into U plus V into T. But by using the first equation, which one is this one, V is equal to U plus AT. Let us take V on the left hand side. We can write V minus U is equal to AT. Now if we take A on the other side, we can write V minus U upon A is equal to T. Okay, now T is equal to V minus U upon A. See here we are using here T is equal to V minus U upon A. Let us substitute this T in equation 2. Let us substitute here. We can write S is equal to half into U plus V into, instead of T we are writing V minus U upon A. Now see here, we know that V plus U, V minus U upon 2A. But what is U plus V, U plus, sorry, V plus U and V minus U? We have a mathematical identity, A plus B, A minus B is equal to A square minus B square. That is V plus U, V minus U is equal to V square minus U square. So we can write this equation, 2A comes here, 2A comes here, become 2AS, become 2as, and V plus U, V minus U becomes V square minus U square. So by rearranging we can write V square is equal to U square plus 2as. This is the third equation of motion, Newton's third equation of motion. So this is the third equation of motion, Newton's third equation of motion that we have seen. Okay, law of conservation of momentum. Let us suppose two objects collide on each other. Two objects collide on each other. First object having m1 is the mass and u1 is the initial velocity, while B object having m2 is the mass and u2 is the initial velocity. After collision, see, initially m1 and u1 is the initial mass and initial velocity of object A and m2 and u2 be the initial mass and initial velocity of object B. After collision, mass and velocity of the both are changes. Now what is the after collision? Let us suppose for object A, m2 and u2 is the new after collision, their mass and velocities are changing. Now we know that momentum is the mass product of mass and velocity. So momentum of object A is m1 u1 and momentum of object B is m2 u2. So when they collide each other, let the force on A due to B be F1. This force will cause acceleration in A and its velocity will become V1. So there is no change in mass but there is change in the velocity. U1 पहले वेलोसिटी था A का, अब वेलोसिटी हुआ है V1 एंड U2 वेलोसिटी था B का, अब वेलोसिटी हुआ है V2. तो आफ्टर कोलिजन मोमेंटम ऑफ A इज m1 v1. Okay, m1 v1. According to the Newton's third law that we have seen, every action force has equal and opposite reaction force. So if B exerts force F1, A also exerts same force but in opposite direction. See, let the force on A due to B is F1. A also exerts equal force on B but in opposite direction. Therefore, we can say F2 is equal to minus F1 because of the Newton's third law. And we know that force is equal to mass into acceleration. So F2 is M2 A2 minus F1 is minus M1 A1 because F is equal to MA. F is equal to MA. This is the formula for the force. Now see here, M2 is as it is, A2 by using the first kinematical equation you can write A is equal to, see here, see here, if we take T on the other side, it comes here, A is equal to V minus U upon T. By using the equation V is equal to U plus AT, we can write A is equal to V minus U upon T. See here, instead of A, we have written V2 minus U2 upon T. And here on the opposite side also, instead of A1, we have written V1 minus U1 upon T. Upon T get cancelled. That one we have used. Upon T get cancelled. And in the next step, we can write M2 in bracket V2 minus U2 is equal to minus M1 in bracket V1 minus U1. So by multiplying and rearranging, we can write M2 V2 plus M1 V1 is equal to M1 U1 plus M2 U2. That is the total magnitude of total final momentum is equal to the magnitude of total initial momentum. So law of conservation of momentum is when two objects collide, the total momentum before collision is equal to the total momentum after collision. So momentum remains constant. This law is called the law of conservation of momentum. The concept map, motion. Motion is related to the displacement, speed, velocity and acceleration. Now what do you mean by the displacement? Displacement is the minimum distance between the initial point and the final point. Speed is the ratio of, or you can say it is distance upon time. Velocity is displacement upon time. Acceleration is rate of change of velocity. Okay, acceleration, motion are two types: uniform motion and non-uniform motion. Non-uniform motion, that means there is a acceleration, there is an acceleration. So acceleration can be uniform and non-uniform. Uniform acceleration calculated using Newton's equation of motion. First kinematical equation, v is equal to u plus at. Second, s is equal to ut plus half at square. And third kinematical equation is v square is equal to u square plus 2as. Laws of motion. So there are three laws of motion. First law of motion, Newton's three law, which one is describes inertia, that shows that three laws of motion, that shows that first law shows if an external force is there, until and unless we applied external force, object remains to rest or in uniform motion along straight line unless an external unbalanced force acts on it. Newton's second law of motion, the rate of change of momentum of a body is proportional to the applied force, and this change in momentum occurs in the direction of the applied force. So rate of change of momentum is proportional to the applied force and in the direction of the applied force. Okay. Now Newton's third law of motion, every action force has an equal and opposite reaction force which acts simultaneously. So these are the three laws of motion. So first law of motion describes inertia. Second law of motion explains rate of change of momentum, and third law of motion states relation between action and reaction force. And one more term we have seen, that is a law of conservation of momentum. And law of conservation of momentum is when two objects collide, the total momentum before collision is equal to the total momentum after collision. Thank you.